2015, this is 2018, number 5, part B. Very short statement here. Find the slope of the line tangent to the graph of r equals 3 plus 2 cosine theta. So we're going to forget about the r equals 4 one at theta equals pi over 2. Nice short sentence. I think this is the hardest problem in the entire set. In fact, I had to look up the answer. I had no idea how to do this. So I had to look it up. So when you look it up, you can do that and make sure you study and understand where they're coming from. So, and by the way, so I'm going to show you their solution, the College Board solution, and I'm going to show you an alternative way to do it that actually Nilla came up with. We're going to look at Nilla's way, because I think Nilla's way is much clearer than College Board's way. So we're going to start with College Board way, and then I'll show you how Nilla did it, and you'll have two different ways to do this problem. They're pretty different, and they both work. So it says find the slope of the line tangent. So the problem that we have is slope is dy dx. All right, slope is inherently a y and x. It's an inherently Cartesian concept, but then we have r and theta. This is in polar coordinates. So when we really talk about slope of a tangent in polar coordinates, we're going to have to convert everything to convert our y's and x's into r's and thetas and see how that works. Because there's basic conflict between the idea of slope of a line, which is a dy dx concept, and a polar graph, which is an r theta concept. All right, so here's where it starts. No matter what way you're doing it, it starts with the idea that since we're asked at theta equals pi over 2, we need to think of the y and the x in terms of theta. And so that means that if we look at dy dx, we can really think of y and x as being parametric functions where the parameter is theta. And then if you think of derivative of parametric functions, it would be dy dt over dx dt, but the theta is playing the role of t. So dy dx is dy d theta over dx d theta. So that's what we have to try and get a handle on, all right? So here's where they start with the book solution. They say, well, let's look at the fact that x equals r sine theta, and y equal, oh, I'm sorry, I have that backwards. Y equals r sine theta, and x equals r cosine theta. So they do expect you to know that better than I just did. And then we need to get a handle on these, dy d theta and dx d theta. All right, so if y equals r sine theta, I can use a product rule and say that dy d theta, all right, so I'm really doing derivative with respect to theta, but there's this extra variable r here. So this is almost like an implicit differentiation. So to do derivative of r with respect to theta is dr d theta. All right, and then, but I'm doing product rule. So this is really, like if I'm thinking of this as f and g, I'm going to do f prime g plus f g prime. So my g here is sine theta. And then I have for my f, I have r, the f is r, and for my g prime, derivative of sine is cosine theta. All right, so that's basically using product rule and implicit differentiation to get dy d theta in terms of dr d theta and r and theta. All right, and then you do the same thing with x, and you're going to get that dx d theta is dx d theta. Using the product rule again, derivative of r is dr d theta. And then this is g, so we're going to keep it the same, cosine theta. And then now I'm going to have plus r times negative sine, because the g prime is going to be negative sine. So let's put minus r sine theta. So that's just using product rule and partial differentiation on those two. All right. So now what we need to do is we have this information that we know that we're looking for this derivative at theta equals pi over 2. So our problem is we have this dr d theta and this r. We need to know what those are when theta equals pi over 2. So let's start with the fact that we know that r equals 3 plus 2 cosine theta. That's just the given function. So I can find out what dr d theta is just by doing a regular derivative. So dr d theta is the 3 goes to 0, and cosine theta is going to go to negative sine theta. I'm going to keep the 2 on, so I get negative 2 sine theta, and that's what dr d theta is. All right, so now I've got a dr d theta and I've got an r. But again, I'm looking at this at theta equals pi over 2. So at theta equals pi over 2, the r equals 3 plus 2 cosine of pi over 2. And cosine pi over 2 is 0, so that's just 3. And dr d theta equals negative 2 sine of pi over 2. Sine of pi over 2 is 1, so that's going to be, well, let me go ahead and write negative 2 sine of pi over 2. So negative 2 times 1 is just negative 2. All right, so then what they do is they take these two values for r and dr d theta, and they plug them into our results up here. So we're going to bring that result down here. And so what we're going to say is that dy d theta equals, so just coming from this line up here, our dr d theta, which is negative 2, sine of theta is going to be sine of our theta is pi over 2, plus r, which is 3, cosine of theta, which is cosine of pi over 2. So that's basically just plugging in the known values of theta, r, and dr d theta into this line up here. And then we can do the same thing with dx d theta. So here's our dx d theta. So our dr d theta is negative 2. And then our cosine theta is going to be cosine of pi over 2. Minus this time our r, which is 3 cosine of pi over 2. All right. And let's see. Yeah, then we can just simplify those quite a bit because the dy d theta then is negative 2 times 1 plus 3 times 0. So dy d theta is just negative 2. And dx d theta, since... did I miss a dx d theta is dr theta? This is supposed to be sine here, right? I thought these two shouldn't match, right? So I'm looking at this r sine theta. This should be sine of pi over 2. I just think those two shouldn't match. So cosine of pi over 2 is 0, so sine of pi over 2 is 1, so I have negative 3 is negative 3. And then I can take that and bring it back to my first equation that I started with, since dy dx equals, maybe let's write it like this, because these are actually evaluated at pi over 2. So maybe I should write that, evaluated at pi over 2. So then I can say dy dx evaluated at pi over 2 is equal to dy d theta evaluated at pi over 2 over dx d theta evaluated at pi over 2. And now we know what those are. It's negative 2 over negative 3. So that's just 2/3. Boom, and that's it. All right, no units, no nothing. All right, so that's the book solution way. So the next video, I'm going to show you Nilla's solution, which I think is you might find easier to follow. But either way, whichever one makes sense to you is good.